All right, welcome back from the break. Next up, we have the aforementioned three musketeers, Ianik Semco, Tom Footit, and Deepak Bhargav from the Product Management Organization for Provider Connectivity. And they're going to be speaking on integrated performance measurements and routing analytics. And please remember that you do have Slido, so you can be submitting questions as they speak, and we'll take them after the session. The floor is yours.
Go up now. I'm going to stay down. Good morning, everyone. My name is Ianik. I'll take you on a bit of a journey inside of XR at the beginning of the presentation. Today we're going to talk about integrated performance measurement, IPM, and routing analytics, RA. So why IPM and RA? We're going to ask, right? We have everything that we need. You're pretty much right that we have everything that we need. Traditional network probing is either between A to Z to monitor service. For instance, an active probing from E to Z will provide the ability to measure a bunch of SLAs. With Cisco Provider Connectivity Assurance, PCA, we can measure 50 plus KPIs, and it helps you understand the service performance. It's accurate, it's granular, and it's directional. There is also probing done between PEs, or at the network layer. We call it between P node and Q node. Things like BFD, Y1731, IPSLA, and more recently, SRPM that was mentioned in the previous two sessions, actually, today. This is active probing from P to Q that provide the ability to measure liveness, loss, latency, and understand mostly the underlying transport, right? So how good are my links? How good is my policy? Am I within SLA, so on and so forth? It's embedded into the network. It doesn't cost you anything. It's in the router. It is flexible. It can do links. It can do policies. It can do SID lists. It can do endpoint inside of a VRF, all of this. And it's pretty prevalent in terms of technology. Now, this is good, but can it be great, right? So there are cases where traditional probing, especially between P and Q, at the transport layer, where traditional probing falls a little bit short, right? The first one is the fact that IP is inherently ECMP, right? So you have a bunch of routers or different nodes, PEs in the network, and they can use different paths, ECMP, equal cost, paths, multipath, to get to Q. And usually what happens is the current probing is not scalable enough, okay? So we have an example of 500 edge nodes at 16 ECMP paths. You see the little blue design. And say, for instance, we want to probe every millisecond. Every millisecond probing, people will say, hey, this is crazy, Ianik. Not if you deal with AI. Okay, so think about that. Sometimes you want to probe easy, sometimes you want to probe aggressive, right? So usually a probe will essentially send, or a probing appliance, a sender, will send the packet towards the destination. It'll do the 5-tuple hash, and then the packet will just take any path on the network, right? So we failed to cover all the CMP paths, right? And with that, essentially, you have some experience, but usually it's inefficient, and you get, your measurement is not covering everything. Therefore, it's like having video surveillance cameras that only look at the front door of a building, right? If you're a warden at a prison, you don't want to only look at the front door. You want to look at the whole perimeter, right? So all the different ways somebody can escape, or here, all the different ways a packet can get to its destination. Network probing, like for instance, between P2Q, SRPM, Y1731, they are a little bit suboptimal latency metrics, right? Min, max, average. Average can actually, average can be a little bit deceiving, especially when you have multiple ECMP paths. There might be one that's really bad, and everything else is fine, right? So your average will actually show a little bit like the green graph, where average says, everything is fine. But with a histogram, for instance, if you were to bin inside of different histograms all the delay packets, you might find out that there is one of the paths, in this example, 12.5% of the clients that have a bad experience on the network, right? So latency will hide that. Or, sorry, average will hide that. Path asymmetry. Obviously, when you do one-way delay measurement, even with a two-way probe, you'll get timestamp 1, then 2, 3, and 4 don't matter if you're doing one-way measurement. So, but when it comes to loss and or liveness, asymmetry of paths, meaning upstream path may be different than downstream, right? So if I see a loss on the path, how do I know it was on the way there or on the way back, right? Another one, and that's the most important one, and this is this graph right here, right? So I have Paris, and I have, where am I going? Madrid, I believe, right? I'm blind. I know where I come from, I know where I go, but the network's a black box. And for tools like PCA, or even, but mostly for PCA, knowing the paths, showing a map is super important. You've seen this in the cold session, one session ago, right? So Paris to Madrid. The other thing is, I'm measuring Paris to Madrid at 15 milliseconds. Great. Is it expected? What's the actual distance? What should be the measurement? Are we good? Are we bad? Right? So sometimes traditional probing falls short. So we need a solution that discovers and monitors all the ECMP paths. Therefore, we need a solution that delivers enough PPS to go through all of this at the rate that's needed, right? So obviously, if I'm operating a WAN, I might not need millisecond probing. If I'm inside of a data center AI backend, I will need every millisecond, right? Or microsecond sometimes, okay? It also needs to report accuracy across all these paths, right? The solution also needs to provide continuous monitoring of the routing, right? You've seen this again in the 9:30, in the 8:30 session. If there's a network change, it changes what's expected, right? Back to, I'm going from Paris to Madrid. What does the map look like right now? Is it the best map? Is it the worst map, right? And then obviously, we need a solution that unleashes the power of analytics. I'm not saying AI, but you can see analytics and AI go really hand to hand, right? So correlate the probe measurement with the routing path. Now, how do we do it? And this is going to be probably the only session where we're going to talk a little bit about the network, the plumbing underneath. But first, it's the integration of three. Kyla called us the three musketeers. One team, one solution, three pieces, right? One piece is essentially the network, the sensors, the measurement, right? Whether you're using the current SRPM or performance measurement probing with SRPM, sensor paths or sensors from PCA, Smart SFP, for instance, or what we're going to talk about, what we're introducing today, IPM. So IPM stands for two things: integrated performance measurement and IP measurement. Okay, so I'll talk a little bit more about IP measurement. That measurement data gets gobbled up into provider connectivity assurance, which will do analytics and path analytics that actually come from Crosswork Network Controller, who knows the topology, right? Time series databases, so on and so forth, feeds all of this to Crosswork Network Controller, which will then contextualize versus or against the service. And we'll show that later on. Routing analytics is one of the key pieces. It provides all the paths from NEP to NEQ, and that at FCS sits into Crosswork. So how in XR, right? So the little green box at the bottom, right, is what what I'm responsible for, and what I will talk about. So IPM, IP space measurement, right? IP space M, right? This is probing built into the fabric. It is an innovation from the SR architecture team led by Clarence Fisfis, where it all started in the hardware itself. Okay, so the most basic thing networks do is hardware. So now, how do we unleash the power of hardware to do probing and measurement, right? So it actually provides scale, richness, and obviously cost reduction because it lives on the router. Okay. The innovation here is not exactly the fact that Silicon One can pump out 14 million PPS. That's okay, right? Where the innovation is how do we inject and log those measurements or these probes at 14 million PPS and then provide the granular experience, right? So the scale and the richness that we talked about. We measured 3L. So what does 3L mean, Ianik? Well, it's simple. Latency, loss, liveness, okay? So each probe, each packet is binned for the 3Ls. And I'll explain a little bit how this works. Now, if you've already submitted your Slido, yeah, what happens on boxes that don't have Silicon One, right? So the DNX, like the NCS or the ASR9K, we are going to do IPM on those across the XR portfolio, okay? But it won't be at 14 million, obviously, right? It will be at BFD rate, okay? We use one-way measurement. Earlier, I talked about network asymmetry, right? Especially for loss or liveness. So it's a technique. Everybody knows T1. The T stands for 2, right? So O1. O stands for what, you think? Yes, 1, right? So it's a one-way standard probe from P to Q, and then you configure another one from Q to P, okay? The probe generation, obviously, is at 14 million PPS per Silicon One device, and Q node can be the target of many other PEs, obviously, and can gobble up to 14 million PPS. We also have a configurable flow label in the IPv6 packet. So you can say, hey, I want my probe to use flow label 52, so it always traverses the same, quote unquote, ECMP or subpath amongst the ECMP options. Or by default, we spray, right? So we go and we basically monitor all the ECMP paths in the solution. Accurate latency and loss measurements, and obviously it's the elimination of the exposure to the return path is what one-way measurement provides. We measure all the ECMP paths, like I explained, right? So each probe packet uses a random flow label. This is in the spray mode. And then we basically send thousands and thousands and thousands of measurement packets every second. Obviously, you can configure that. Measurement takes bandwidth, so it depends on the environment you want and what you need, okay? We're reporting the experience across all the CMP paths. How do we do this, right? So each probe measures the 3Ls, okay? So latency, loss, and liveness. Latency is essentially binned into what we call a digital histogram that can be of different sizes based on the needs for the measurement or the distance between the measurement points, right? And it will report the whole experience or the experience of the whole population earlier on with a histogram. Basically, we are quote unquote ignoring average, and we're showing you the outliers also, right? So in that measurement period, most of the ECMP paths were here, but one was bad. You may want to look here, right? And then the magic happens at PCA to actually show you all of this. For loss, we use absolute loss. So today, especially when we do transport probing, we count the packets. Okay, so receive minus sent equals loss, right? Here we do a little bit more, right? So we use a technique called alternate marking. Actually, this was also talked about yesterday when Telecom Italia was on stage, right? So alternate marking is the technique where essentially we have a a blue and a red counter, and then we send traffic against the quote-unquote blue counter for, say, a minute, right? Then we switch back to the red counter. Why? Because if you've done any traffic measurement, you have to stop the packets, right? If I send 10,000, then I know what I expect, and I can essentially get an absolute loss measurement out of it. And then also liveness detection. Liveness detection is like BFD concept, right? So if I lose 3 consecutive packets, I have a liveness event, right? So that's what it is. Now you're going to say, hey, this is proprietary, Ianik. It's not, okay? So obviously not. It's a standard-based measurement. We use STAMP, and I think one of the RFC authors is in the room. So thank you for the great idea, right? The packet format is any IPv6 header, right? Because we need the flow label. So the outer encapsulation header can be any IPv6. Obviously, our focus is mostly for SRv6, right? But it can be GREv6 or VXLAN v6. And then the stamp measurement packet is the green part where we do the alternate marking counters. Is actually we take 4 bits out of the flow label to do bit 17 is the red or the blue. So am I measuring right now on the red alternate marking counter or the blue, right? So that's how we know how to do loss, but also shoot up the telemetry when we switch from one to the other, right? Obviously, PCA needs the data, right? So we monitor the shared transport and the service forwarding path on the PEs. In iOS XR, right off the bat, when we FCS, which is probably going to be 25.4.1, so end of this year, maybe early next year. I'm a product manager, so if I set your expectations, I'll say first half of 26, and then I'll try to over-deliver, okay? You can configure, obviously, your source address, your destination address. You can have a VRF in your probing packets that will do 3 Ls. Configure different DSCP values, right? And then 2 modes of operation. By default, it's spray. So we use randomized flow labels to cover all these CMP paths. Or dedicated flow labels. If you're asking me, how do I deploy this, Ianik, right? Well, first I do SRPM on the links. I need topology, right? And then what I might have is a session that sprays, and then a few dedicated flow label sessions that will essentially hit, that outlier, right? So I want to know what is the exact experience for, say, an outlier. So I may have 4, maybe 6 different, specific flow labels so that I can monitor all the subpaths. And then I may also have 2 or 3 different DSCP values, because obviously when there is congestion, the better DSCPs should be less prone to congestion. And obviously latency is very influenced by congestion along the path. We use explicit session IDs. Again, if I'm the queue node and I'm getting bombarded by 1,000 PEs at millions of PPS, I need to know who's talking to me as I'm binning the things in the different histograms, right? Or the different loss counters. And then obviously, we do support SRv6 traffic engineering policy or SID lists. So I can now, with my IPM probe, I can also mimic the path of either ride on top of an SR policy or mimic the path, right? So I want to measure from Paris to Madrid, but I want to see what it looks like if I go via Berlin, right? So essentially, I can have an IPM session that I can configure with a specific SID list, right? Whenever we change the alternate marking, we wait a little bit, right? Then we shoot up a bunch of telemetry, okay, on the queue node. And this is where the fun begins for especially most people in the room, because now I can build and decorate a lot of the tools. PCA obviously is the first application to benefit from this, but obviously your own applications, it's just an XPath in iOS XR, right? Now, obviously, there is also an event-driven telemetry engine. For instance, hey, I just detected liveness. Well, I'm not going to want to wait 5 minutes to say there was a liveness event or there was a threshold crossed, right? Because obviously on the queue node, you can say, hey, you know, if you cross this threshold, let me know right away, right? So that's the EDT. But then there's also model-driven telemetry. It also comes with description. So, you know, whenever you feed this to Splunk, for instance, you can have description on your probe ID. So you could say probe ID 55 is for Ford Motor Company, right? Between Detroit and New York, for instance. And that, for instance, Splunk would basically now know to map this with whatever VPN Ford has configured and so on and so forth. So it enables a bunch of good things. So that was the part about iOS XR. I'll invite Tom to talk about how PCA participates in the solution.
Thank you, Ianik. Okay, so let's talk a little bit about what this means for provider connectivity assurance. All right, so Ianik's responsible for the green part on the bottom. I'm responsible for the orange part on the top left, right? So our role in this combination of three, one solution coming together, is to collect that data, understand it, analyze it, interpret it, allow you to visualize it, right? And then allow you to trigger action on it in CNC, where Deepak will talk about that at the end. So really it's about, okay, I've got a lot of P's and a lot of Q's in my network. I got a lot of probe packets. I got a lot of data. What is interesting? What's abnormal? What should I try and tackle? And so our role, again, is analyzing all that data and providing insights into it. So this slide got a little bit messed up, but that's okay. So essentially, Ianik mentioned this at the beginning, right? I'll go through it again. But when Exceeding was acquired by Cisco 18 months ago, right, we deployed probes from A to Z, right? Sensors, we call them, right? That sit on the A and the Z end, hardware, software, whatever it is, and they're pushing TWAMP packets across that network. And as Ianik mentioned at the beginning, that gives you very accurate one-way measurements that allow you to understand what's happening to a customer's service from A to Z. But one of the questions that we always got was, okay, well, what happens in the middle, right? I'm seeing a latency change. I'm seeing some packet loss. I'm seeing, something wrong with my service. What's happening in the underlying network? And as Ianik said a minute ago, for PCA, the network was always a bit of a black box, right? We push T1 packets across it. Yeah, you can adjust the DSCP values and the VLAN tagging and all that other kind of stuff, the VRF and so on, right? But, we don't really know what's happening in the underlying network. And so really there's the two technologies that are helping us now understand what's happening in that underlying network are IPM and routing analytics, right? So integrated performance measurement allowing us to, as Ianik just described, push packets between all the different P and Q paths, all the ECMP paths between P and Q, and then understanding what the actual path is, which is what routing analytics is. Deepak will talk about it in a second, but essentially it's us taking a BGP LS feed from the network, analyzing those paths, and understanding, okay, I understand the ECMP path or paths being taken between P and Q. So essentially what we're trying to do is sort of put those things together, right? And my little puzzle here on the left-hand side of the slide. So I can combine measurement of the A to Z session using probing. I can understand from that session how the network is behaving between P and Q, where A connects to P and Z connects to Q. I can understand the performance with all the detail that Ianik just talked about. And then I can understand that path, right? And I can do it not just instantaneously right now, but I can store the history, right? So again, part of doing the analytics is being able to ingest all that data, store the history, and understand, okay, we understand historically how things have been behaving and how things are changing, and then to be able to correlate the behavior in time. So for example, if we're seeing a latency latency or we're seeing loss issues between A to Z, I can understand what was going on in the underlying network. Was there path changes going on rapidly, potentially flopping issue that led to some packet loss? Were there path changes that went along, that happened, that might have caused a latency change? As Ianik mentioned, maybe that's expected, right? Maybe that's just the path and there was a fault and the path changed and that's okay, right? The latency change is okay based on the underlying network. But the ability to correlate those things together and see them together is the power that we're trying to bring. So you saw this earlier, if you were in the room earlier for Amish's session with Colt as well. But basically what we want to be able to do is provide a network-wide view of all the P to Q paths, right? So this dashboard in PCA is basically saying, hey, I'm looking, in this case, you can change it, but this is average propagation delay between all the P and Q paths, right? So essentially you're saying, hey, look, I can see all of my edges, all of my P's and all of my Q's in one view, right? So, as Ianik mentioned, that's millions and millions of packets, right, that are rolled up into measurements from IPM. And then, you can look at them over, this is an example over like a week, but it could be over a month or a year, whatever you want, right? So in this one view, you can roll up and aggregate tens of millions, hundreds of millions of measurements in one shot to sort of say, hey, what do I care about, right? Where are my potential latency issues? What's changed over the last little while, right? And so you can get that big picture view of how your overall network is performing between all those different P and Q paths. And then you can also say, okay, I want to drill down and see a specific path, right? And again, this is looking over a longer period of time, but essentially saying, hey, I've got a situation where this is the path between these two sites. I can see path changes. I can see ECMP changes. I can look at the performance over time. I can look at the ECMP changes over time. I can say, okay, I understand, the ECMP health over time. Are there paths that are not delivering on equal cost? And I also want to be able to correlate that to that overlay probe, right? So I want to be able to draw a line over top of this that says, hey, this, maybe I didn't pick the best example, but, because it's relatively flat, but hey, when I'm seeing those ECMP changes, am I seeing the overlay probing data change at the same time? In other words, I'm doing the correlation between that P to Q and that A to Z view in one shot. Now we do have a video of this at the end that will show, and it'll actually show how a PCA can work with CNC, with Crosswork. So I'm going to hand it over to Deepak to talk a little bit about Crosswork, and then I'll come back at the end, and like I said, we do have a video that will show that shows how this actually looks in action and how Crosswork and PCA can cooperate. But before I steal Deepak's thunder, I'll let him go ahead.
Thank you, Tom. Okay, so I'm going to talk about the third component in the solution, which is the Crosswork Network Controller. And before I get started, I think I want to just highlight how we're going to take advantage of some of the granular, accurate data that we're going to collect from IPM and take advantage of the analytics, deeper analytics that Tom talked about. So in this, what is first CNC? I think many of you already know CNC, so let me just summarize what CNC is. It is the SDN controller for the IP transport domain. And what it uniquely brings in is the combination of device management, service lifecycle management, as well as the workflow automation to deliver the closed loop operations, all integrated together in a single offer. And in this solution, we want to take advantage of the IPM-based insight in many of the functions that the controller implements, like the service health monitoring and troubleshooting, where we can take advantage of the IPM analytics to enrich the way we characterize the service and how do we troubleshoot, taking advantage of the PCA analytics. And we are going to go deeper, and of course, you'll see that in action in the demo as well. as well as in the traffic engineering. Earlier, Krishnan talked about traffic engineering. And again, the performance data plays a role especially when we are defining the traffic engineering policy for services that are low latency applications. And then the other area that we intend to take advantage is when we identify anomalies based on the IPM data where we need to take an action. For example, if a customer is experiencing latency on their network, and if that is going to impact the SLAs, it is quite important to take an action. It could be maybe I'm pushing certain configs, changing the QoS policy, or manipulating the affinity flag, or some action that I can automate as a part of the closed loop operation. And lastly, in the Crosswalk network controller, what we are quite excited to kind of mention that we intend to bring in the routing analytics. And that adds completely new dimension because now, as what Ianik mentioned, now we can see all the ECMP paths between the P and Q. Of course, there are many, many nodes. So between any of the two node pairs, I can look at all the ECMP paths. And that helps in many use cases that we are going to talk about in the next few slides. So just going a little deeper in terms of the routing analytics. Before we get there, let me point you to this screen capture, which is a view from CNC topology visualization. And topology visualization is quite key from the operations perspective. And actually, customers love it, the way they look at the whole service topology, the network topology, and ability to drill down from service to the underlay transport, and then, of course, going deeper into the devices and inventory and so on. But as we look at this topology, I think as we mentioned, the routing analytics augments it because now I add another layer to it. So if I'm looking at a service and I select a couple of endpoints, I can now look at all the ECMP paths between the 2 points. Like in this case, it's node 4 and node 5. And when I look at all these paths, I can also overlay that with the propagation delay that I can get with the route analytics, as well as I can get the information about if there is a change in the path. And that becomes quite important because when the path changes, that could be resulting in potentially the degradation in the latency, or could be impacting the services. So this insight that we gather from the route analytics becomes quite important. Let me take an example. Of course, sometimes we think about that the end customer is facing latency issues and on their VPN connectivity. And then we come back and say, well, the network seems to be performing within acceptable range because we are possibly using some of the traditional monitoring technique that Ianik talked about. So maybe we are missing on maybe some of the paths. We don't have all the visibility into every ECMP path. We may not have the richness of measurements that we have at that level of granularity. And we think that the network is still performing within the acceptable range. And that is where the need for that deeper visibility and the analytics that Tom talked about, the visualization, and be able to pinpoint to exactly what path, although the average may look good, across between P and Q, but there is one path which is a culprit that is causing that degradation for certain type of traffic or on that VPN. So that is where the route analytics plays a key role. Now, if we talk a little more about this, there is something I think wrong again with this template, but let me just talk through this. So what this is trying to talk about is routing analytics helps us define or benchmark some of the measurements. So if we talk about just latency, and I mentioned that the routing analytics help us give us the end-to-end propagation delay. So in this network, when we are looking at the traffic going from Paris to Rome, we can see that on this topology, the path is as shown on the green hops. And from the routing analytics, we can find out that the end-to-end propagation delay has to be like 12 milliseconds. But we may be seeing that the measured delay is 13 milliseconds. And why is it 13? 13 is just an example. It could be even more than 13. And that's what reflects the current routing delay. And when there is a significant deviation from what should be the baseline, then I think that's where we need to start investigating what is causing that and which path in the network is actually leading to that increase in the delay, which can impact my service performance. So now let's talk about how we intend to take advantage of this, the analytics, the IPM analytics as well as routing analytics. So there are a whole bunch of use cases that we intend to enable. The first of the use cases is the service and transport topology visualization. So of course, when I look at the service topology, the first thing I want to do is I want to understand how the service traffic is traversing the transport. And if I can augment that visualization in terms of the ECMP paths, that helps me then, correlating with the measurements that I get, identify when there is an issue, where is the issue coming from. The second use case that we intend to take advantage here is traffic engineering. So in traffic engineering, like I think Christian talked about, like why do we need traffic engineering, right? So if I have a service which requires, it's a low latency connectivity, so I want to minimize the latency. So I need to define a policy that can address that particular objective and may also need to take care of some of the constraints I may define. So when I'm trying to design that policy, I want to look at between the two endpoints, what are the different ECMP paths, what's the latency bound, and I can see the range of latency that can be delivered across the paths. And I can then assess whether I need to take advantage of the default IGP forwarding as a part of the policy, or tie the policy to a specific flex algo, which is going to deliver me the low latency that I need for that particular policy. So that's an example where I can take advantage of the routing analytics as well as the IPM. Also, I can take the IPM data in terms of incorporating it into the optimization algorithms as I deliver the services for latency-sensitive applications. Another area is the service health monitoring and troubleshooting that CNC has. And before I talk about how we want to take advantage of this, let me point out that there are two key challenges we are trying to address with the service health monitoring in CNC. The first challenge is when we provision a service, sometimes we think that monitoring is afterthought. It's a day-to activity. But of course, the end customer wants to know that service is up and running and it's meeting those SLAs. So what we enable in the CNC is ability to activate the monitoring at the same time when we provision the service. Right? And the second challenge is, which I kind of mentioned earlier, is when the end customer is experiencing the latency delays, but the network seems to be operating well. So what we try to do in the service health monitoring is to model the dependency between the services and all the underlying infrastructure components, whether it's data plane or the control plane components like BGP health, PSUP health, data plane. And that is done because we also monitor the health of those components. Any of the components that get degraded could impact the service health. So that way, we can isolate where the issue can be. And if it's a data plane issue, then that's where we get to the analytics from PCA, look at all the ICMP paths, and try to exactly pinpoint which path is causing the latency to solve that problem. Which otherwise, if we don't have the visibility, it could even take days to solve it. Now, with this visibility, I can quickly pinpoint what is the underlying issue. And then lastly, as Tom mentioned, closed-loop operations or automation plays a key role, because often when I see that a customer, there could be a risk, SLA risk, because of the latency gradually increasing, I want to take proactive steps. And that whole closed-loop automation is about really connecting the insight to the actions I may want to take. So in this case, if I'm seeing, based on the IPM analytics, that it's going to impact the SLAs, maybe I want to push certain actions, like I mentioned, maybe change the QoS policy, do some traffic shaping, prioritize certain traffic over others to be able to manage the latency between the links. There could be many other actions, and actually we'll see another action as part of the demo. So over to you, Tom. Let's go through the demo and see the whole solution in action. How do you bring together all these capabilities, right from the visualization of the paths and the analytics with respect to the performance, and be able to take the action when the latency is impacted?
All right, so I'll see if I can get this going this way. I wanted to be able to stop and start this. We did a video, and I wanted to be able to stop and start it, and apparently the way to do it is with my laptop. So, it works. All right, so we're going to start this journey in CNC. I'll say a couple things first, right? So one, this is a prototype of what we're planning to do, right? As Ianik mentioned, IPM is unavailable, and some of these features in CNC and PCA are on the way as well. So this is a work in progress, but we wanted to sort of show you what we were going to show in motion, right? So watch a demo and see how we see these three pieces coming together, right? So we'll start in CNC, as Deepak mentioned, right? You could be starting looking at, okay, I've got a topology view. I can look at the services running over this topology, right? I can see maybe there's one from Berkeley to Seattle here that's running, right? And so I want to look at the details of that service. And so, first time I'll stop, right, is being able to say, okay, well, right now I have some data that's providing some information about that service health, right? One is could be coming from IPM data, it could be coming from probe data that traditional PCA probes, or coming from IBM probes, right? So I want to be able to understand. I want to be able to add it, right? So the first thing I'm going to do is I actually want to be able to provision the IPM probe. So as Ianik mentioned, get ahead of myself. So as Ianik mentioned, right, you can provision iOS XR, the PN, the QN, right, to be able to generate this. You can configure, the DSCP values, the VRF, all that kind of good stuff, right? Number of packets per second you're going to send, whether you're spraying or not. So basically, we've kind of hidden the details behind this, but essentially you say, okay, I want to be able to provision an IPM probe to go between the P and Q that's underlying this service, right? And so, we'll basically say, okay, I provisioned a probe, and sped up for the purposes of the video, I can see now that I'm getting, I've got an IPM session up, and there's some kind of degradation, there's some kind of problem, right? The service is degraded somehow. And so what I want to be able to do is go understand, okay, looks like I have a latency issue coming from IPM, right? Let's look at the assurance graph and understand all the different pieces that are contributing, as Deepak mentioned, right? So I've got this service from Berkeley to Seattle, and there's a bunch of different things that are contributing to the health of that service, right? Whether that's control plane, data plane, right? And so basically adding IPM to this. So now I can say, okay, I understand that there's IPM data that is coming from PCA into CNC, and it's informing me that I've got some kind of issue, right? Something's not working well. PCA's analyzed the data and said, hey, I'm going to tell CNC that I've got a problem. And so that's happened already, and now you can see in the service graph in CNC that we've got a degraded service. So I want to be able to look at that and see it in some detail. So I'm going to be able to pop that up and say, okay, I want to be able to analyze that in PCA, right? So PCA has told CNC that there's some kind of ECMP health issue with this service. Now I want to go figure out what that is, right? So being able to cross-launch that into PCA will give me that same, contextually, that same Berkeley to Seattle service, right? And you saw a little bit of this earlier. I can look at the various ECMP paths that have been have happened for this service over time, right? A, B, C, D, right? I can look at those things and understand that, okay, my service has been taking different paths over time, right? And so I want to be able to look at all those paths and understand what's going on. Now, the first thing I'll do here is say, okay, what's this like? This weird-looking heat map at the top, right? What's going on? And what that's trying to show is, and I'll show it in a bit more detail in a second, if you remember, Ianik at the beginning showed that the histogram binning of the IPM measurements, right? And so what we're trying to show is the binning showing us a nice normal distribution, or is it showing a binomial or multimodal distribution bimodal or multimodal distribution of the data? And so I'll show this in just a second by letting it play. I can look at it and say, okay, right, this, when I have path C going on here, I've got a distribution of my latency measurements in that binning that IPM provides coming from the router on the path here from P and Q between Berkeley and Seattle. Well, the average is nice. It's really weird, right? I should have a healthy path. I should have a nice normal distribution, right? Where I've got a cluster of measurements around the center, but here I don't, right? I've got this bimodal distribution, which is not good, right? It's supposed to be equal cost, and here I have basically two paths performing very differently. So I don't have equal cost measurements. Whereas if I look at it where you can see the hot part in the middle, I do, right? So when it's taking like path A over here, it looks like, that's pretty healthy, right? I'm getting a pretty good normal distribution of the data. I'm basically getting equal cost through my network, right? So I'm not having a problem there. I'm only having a problem with ECMP on some of the paths, right? And I can see which paths are causing a problem and which ones are healthy. And so right away now I can understand, okay, right? I've got healthy paths and unhealthy paths, right? And so based on that distribution, I can look at the history over time, what's happened with my path, how often it's occurred. You can see how often, A, B, C, D, these different path changes, but I can see when I'm healthy and when I'm not healthy. And so that allows me to understand, okay, let's go back to CNC now and say, okay, I can take action on that, right? So based on the analysis from PCA, I know which paths for that service from Berkeley to Seattle have healthy ECMP and which ones do not, right? And so I want to be able to try and take action to adjust and change that, right? So I'm going to go execute a workflow that's going to exclude a certain path. Click, 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 right? So I'm basically going to say, okay, I'm going to make a change to my service to exclude that unhealthy path. Probably need to go figure out what's going on there, but I want to make a change to be able to exclude this unhealthy path. So I'm going to be able to go and run this workflow in CNC. That's going to make a change to that service. And then, obviously not that instantaneously. My video is designed for my demo, not for real life. But the data would show up and say, okay, yeah, healthy, right? Boom. I've excluded that unhealthy path that's got an ECMP problem for my service, and now my latency and my ECMP performance is back where I expect it to be. So basically what we wanted to be able to show you is, hey, I can take this IPM data from the network and this routing analytics data from the network to understand the performance from P to Q and the path taken from P to Q. I can collect that in PCA, analyze it, and then I can use crosswork to take action on it, right? So it's not just insight, it's actionable insight. And it allows you to say, I can measure my network, I can understand my network in detail, I can look at it in a user interface in detail, but most importantly, I can take action on it, right? I can resolve a service. And so that's our presentation. There is a follow-on to this afternoon at I think 3:30. We're going to go into some more technical detail around APIs, look at the details. Everything we've done in the user interface for both PCA and for CNC, you can do via APIs as well, right? So, obviously it makes a nicer looking demo up on the screen here by looking at the user interfaces, but you can drive automation with all this, right? You can automate the service creation, you can automate the IPM session creation, you can automate the data collection in PCA, you can automate the alerts coming out of PCA, you can automate the actions you take in CNC, right? So this is all automatable. And the session later this afternoon will go into how that works in some more detail. So if you're interested in seeing APIs and under the hood a little bit more, you can tune in, I think this afternoon, I think at 3:30. Okay. Kayla, any questions?
Yes, there are.
Okay.
Welcome back up. We've got a few questions from the audience here. We'll start with the first. What is the performance hit on a device with Cisco Silicon One when running this at max config?
So the answer is none. So there's no performance hit because what we use, it's actually, so the packets are generated and binned inside of the host CPU on the Silicon One chip, which essentially does not alter the NPU, the data path.
Great. Does it matter where we place the probe in the network, what we can measure, and how precise the measurements are? For example, if we want to measure the SLA port of a customer.
Yeah. So again, for me, I guess.
Yeah.
So we recommend everywhere. Okay, so from every P to every Q is the recommendation. So it somewhat matters where probes are placed. Obviously, if I want to do Berkeley to Seattle, I need probes between Berkeley and Seattle, but it's also good if, for instance, well, Berkeley and Seattle is going north, but imagine San Diego to Seattle, right? Maybe I want to also do San Francisco to Seattle, right? So that I have the experience also in that, how do I call this? On the way segment, right? So the more probes you have, the more P's and Q's you have, the better the experience and the more relevant the data becomes.
Yeah, P prime to Q or whatever else,
Exactly.
right? It's also possible.
Yeah.
Sure. Is it good practice to put probes on managed? So Kayla,
Go right ahead.
jumped here. I was reading ahead. So put probes on the managed CE devices, right? So again, right, what we're trying to show here is that depends on your use case a little bit. Maybe Ianik, you can jump here too. But essentially, depends on your use case, right? So our more traditional PCA probes are typically what we would run from a CE device, right? To sort of say, hey, I'm just trying to measure the SLA here, right? So I want to know like customer service, IPVPN from data, this building to that building or that data center or whatever else. I'm going to use a more traditional T1 probe. But really what this is trying to combine that with understanding how the network's behaving, right? So, a more traditional PCA probe is how you would typically do like an SLA. But then this is really about tying that SLA performance to the behavior of the underlying network, I guess.
So yeah, so it's a solution in the applications, obviously, where information is shared, but it's also a complementary solution at the network level, right? So like Tom is saying, right? So I want service A to Z, right? But wouldn't it be nice if I also had the experience of P2Q, right? So if P2Q is all green and A to Z is bad, well, the problem's at your end, Mr. Customer. It's that simple. Yeah.
So I guess it depends on the use case, where you want the visibility, where's the delimitation where you want to see where the latency issue is, right?
Exactly.
Next up, is this only applicable to SR services policies, or can it be applied to normal transport services, for example?
So long as it's IPv6, IPM will work. So it doesn't have to be on a policy. It doesn't have to do SRv6. It doesn't have to. SRv6 is 95% IPv6, guys. Okay, so it's an IPv6 packet. It just is smarter and more programmable because of the SR behavior. But at the end of the day, it's an IPv6 packet. So it works on anything that is essentially IP.
Okay, and Tom, for you, how does it work in a multi-vendor environment, propagation, delay measurement using IPM and PCA?
Right. So, this is partially Ianik.
It's RPM.
Yeah. Well, so you answer the IPM multi-vendor question.
Yeah. So the IPM multi-vendor is simple, right? Again, it's a stamp standard packet, right? So it looks like a T1. If obviously I can't use today another vendor to be my queue, right? But there is also what we call the legacy mode, where I can do an IPM session back to myself. Yeah. Okay. We didn't show it here because we thought we would run out of time. But essentially, I can generate and receive my own IPM packet because of, and now we use the beauty of segment routing. I can loop back that packet through any node in the network, right? So I'll be both the source and the receiver.
Yeah. So in that situation, P might be a Cisco Silicon One device, or either when it comes to other chipsets as well. But Q could be another vendor device, and again, Q's not going to generate IPM data, but you can loop it back and get the data there. And in terms of the rest of the stuff we're doing, everything else is all multi-vendor, right? So routing analytics is just using BGPLS. There's nothing specific about that. That's Cisco. And then the PCA probes are all things that also work in a multi-vendor network, right? So really the only piece that is Cisco specific in this is the ability to generate and collect that IPM probe data, right? So that's the Cisco innovation.
There's an advantage to use Cisco devices, but obviously it runs on when the network is brown also.
Exactly, it works multi-vendor, yeah.
And how is the link by link delay measured for the ECMP path?
So that's another one for me.
Yeah.
The same as before, right? So this is SRPM link measurement, right? So you go on your link, you say performance measurement, it gets enabled, right? And the timestamping is done in the hardware, so we measure the speed of light.
And second to final question, can provider connectivity assurance monitor interfaces on the devices together with the IPM and routing analytics?
Yeah, for sure. So that's one of the things that you can absolutely do. And I kind of glossed over on the one slide I had earlier, but essentially you can say, okay, I want to be able to take, I understand the path the service is taking, right? So routing analytics is one of the things that helps me understand, where the service is going on the network. And I can be taking telemetry from those devices, right? So it's actually an extra layer. Again, for sake of time, we didn't get into it as much today, but you can say, okay, I'm going to combine A to Z traditional PCA, let's say T1 probes. I'm going to combine that with P to Q IPM measurements, and I'm also going to start taking, for example, some port statistics or some other measurements off of devices in there that might help you understand, for example, why the issue is occurring, right? I'm dropping packets, I've got a queue that's full, right? That kind of stuff. So you
Carbon.
Yeah, the example that was done earlier, right? That Amish did, right? Pulling power information to convert that into carbon. Those are other statistics you can pull from the network at the same time as well.
Great. And last question, can you tie in external BGP routing analytics to the performance?
Yes. So if Q is the BGP next hop, it'll help, right? Now, obviously, you could correlate, but this is not essentially made to monitor the TCP session, for instance, between two BGP peers. But obviously, if it takes too long, if there's a lot of jitter, then it may affect the TCP windowing technique that BGP uses. So it can be tied, but loosely, I would say.
Yeah.
We did actually get a couple more in, so I think we have some time.
You need to answer one.
Yeah. There's a CNC question.
Yeah. How much of the computational resources these analytics impacts on CNC's infra?
Yeah, no, it's a good question, and we have done some analysis on it, so we anticipate not significant. So it should not be of any concern.
Okay, perfect. And the real final question, how are the hop identities reported in an SR path with loose hops?
You again.
In terms of the, so this is more for the visualization, the question. Can we clarify what that question is?
This is, so maybe I can try to rephrase, maybe. If it comes from online, I don't know if you can redo. But I guess I have an SRT policy, right, between San Francisco and New York that has to go via Dallas, right? So how do we see those hops?
So we should be able to look at that as we drill down from the service to the transport, we should be able to see those policies.
And obviously there's, okay, so I mentioned it in my section, but obviously I can also have an IPM session that rides on that policy.
That's right.
Right. So imagine I have IPM that goes that basically monitors San Francisco to Dallas via the quote unquote any path, and then San Francisco to New York via any path, and also San Francisco to New York via Dallas. I think I have all the information I need to make good decisions. I think we're borrowing on somebody else's
Yes, we
time.
are. So, Sasha, maybe you can find the guys at lunch and around the beta trial as well. Please track the Three Musketeers down here at lunchtime after this final session. Thank you very much. Lots of questions. Thanks to the audience as well for all the questions.
Thank you.